Let's start. Today we talk about few topics which are all related to the same concept. So let me open Notepad. So we'll be talking about like NodeSelector and Taints Tolerations, and we talk about Affinities. So let me give you a scenario, why what are these, and why we require all of these things. Let's say have a cluster and have, let's say, 10 nodes within the cluster. I got requirement that I want to run a specific deployment. I have a deployment, test deploy something. I want to run that specific deployment in only one node. Out of 10, I want to run only in one node. So usually what happens is, now currently we don't have any that kind of restrictions. When I deploy, it will deploy randomly. I mean, it's not just specific to one node, it will be deploying randomly. So there is no restriction, something like that. But we may get a scenario of, not may get, we'll usually get these scenarios. I want to run this application only in that node. Why? Why need to run that? Maybe the node has some dependencies. I mean, the application has some dependencies which specifically on that node, or that node maybe have high memory, high CPU. So my application want to run in that node so that it can handle my application, the load and everything. Remaining all servers are less configuration. So these kind of scenarios. So you have a requirement or restriction where you want to limit the pod, I mean, to a specific node. So other times these things will be helpful for you. So what happens is, let's say, let's start with this one, NodeSelector. NodeSelector is something like, it's in, as I told you, right? It will restrict the pods to specific nodes. But how? How it will restrict it? Based on label. What label and where it will be there. So based on label per node. Let's say now what my requirement is, I want to run in that node. What is the name of that node? There will be something, right? What is the configuration of that node? There will be something information about the node. So based on that name, I want my pod to be running in that node. Let's say, as an example, I have 10 nodes, as I told you. Out of that, I want to run pod in the node where the name is test, as an example, let's say. So now this NodeSelector, what it will do is, it will look for all the servers. I mean, it will check all the servers and find out which has this label called test. The name is equal to test. If the name is matching, it will deploy the pods in that node. If the name is not matching, it won't deploy. Correct? So let's say out of 10 nodes, we have 5 nodes have the same label, name test. Test label is there for 5 nodes. It means the pod will be deployed on 5 nodes. Let's say all 10 nodes have the same label, it will deploy on all the nodes. If it is the label is only 1 or 2 nodes, it will deploy the pod in only in that particular node. Got it? But usually, how it will be deployed in that particular node? We do have a master component, this scheduler. This scheduler usually decides where the pod should be deployed. So now, since we have the label, we want to run this pod only on this particular node which has the label. Scheduler will check that. Scheduler will check, okay, we have some restriction. We have to see whether this label is matching or not. If the label is matching, it will run it. If let's say there is no label at all, I mean the name test, whatever the label we have, It's not at all present for any of the servers in the cluster. Then you know what happens? It will be in a pending state because the condition is not matching. We added a condition. Only deploy the pod in the node which has this label. No node has the same label. I mean, no node has the label which we mentioned. It don't know where to deploy. So it will be in a pending state. So usually like that, it's a pretty straightforward the way of working. Other two also work similarly, but let's see after that. First, let's see this one, node selector. All we have to do is define this setting in manifest file, our manifest file, the node selector configuration, and based on whatever we gave, it will try to deploy. I mean, the scheduler will try to check for the label and try to deploy whatever we gave inside the label. Let's say I can define node selector like maybe disk type is some ABC something, or memory something, or let's say OS name something. Anything. It can be anything. Whatever the configuration, whatever the details of the node has, it can be anything. It will you know try to run the pod based on that. Got it? Let's try that. How to do it? Let's see. So what I'll do is I'll add this node selector configuration based on maybe label, some test label. So let's first see the nodes. Yeah, they are ready. Vi test and deploy. Sorry. So deploy. This is ours, obviously. Now what you do is you simply add the node selector. Where do you add? You can add it here or you can add at the end. Anyway, it's fine. Let me add in the end also. That is also fine. Node node selector like this, and below the label you have to give based on what you have to. I mean, what condition you have to give here. It can be anything. Let's say I'll give name colon test. It means it will try to run this deployment. I mean the pods in the node where the name is equal to test label is exist. Let's try that. That's it. That's about the node selector. Let's save it. Let's apply. Created kubectl get deploy hyphen n test is nothing. See 0 by 3. Get pods. Let's try. They're pending. Why they're pending? Let's describe. Let's see there. It says some error. 0 of 2 nodes available. It did not match the pods node affinity or selector. It means whatever the selector node selector we gave, right, name is equal to test. That is the label does not matching with any of the existing nodes. Simply it means we have 2 nodes in the cluster, of course including the master. For those 2 nodes, there is no label called name is equal to test. It seems that one. How do it knows what labels are there? Let's check get labels. Get is there labels nodes try. Oh wait. At least one or sorry, let me check the command. What is it? I forgot the command. Get labels. By default there will be labels. Oh yeah, get nodes hyphen show label. Sorry, my bad. Let's enter. See, this is yours. This is blah blah blah. See labels. These are the default labels. What we have for, and these are for the node obviously. If you observe, is there any label called name is equal to test? We have beta dot Kubernetes IO AMD64 beta dot Kubernetes IO OS Linux blah 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 something. But do you see any label name is equal to test? No, right? It means That's why they are in pending state because there is no label. Of course, if you use this any of these labels, it will work because these labels exist. But the name, whatever we gave, does not exist. So what you can do? So if you have these are default labels by default, it will come along with the nodes. So now this name test is a your own label, right? It's custom our own label. So what you do is you can set a label to any node and use that label in the configuration. How to set it is kubectl label nodes. What is the node name? This is the one. Paste it. What is the name? Sorry, name is equal to test something. Label is set. See now name is equal to test. So now our condition is matching, right? So what we told deploy pods if a node has this label. Now it should be running pods. Let's see. See, it's running in 220. Sorry, the same machine. See. So based on the label, it will deploy your pod in the node selector. If there is no label, label is not matching, obviously it will live in a pending state. Got it? Is it clear?
Yes.
So that's about node selector. This is one way of doing it. You can deploy, sorry, you can delete it because we'll be showing it again. So based on the labels, node selector will work. And there is something called taints and tolerations. What are these? They are also a little bit similar. Controlling which parts should be deployed on a specific node. Same thing, same as node selector. So we want to deploy specific nodes on specific parts. So we'll be using taints and tolerations. But that's the same thing for node selector. What is the difference? What is the difference is the way we set it. That's the difference. So let's say sorry, we have something called taints and tolerations, correct? Taints is something which we apply on the nodes. Same thing, just like label, we applied a label to the node. Similarly here, taints we apply to the node level. And what is tolerations? Tolerations are applied to the pod. So if taints and tolerations, taints we apply on the node, let's say taint name is equal to test as an example, I'm just saying. And toleration we are applying on the pod, name is equal to test. If these two are matching, it will deploy in that node. If these two are not matching, it won't deploy. So both are similar if you observe, but the way we define that, that's the difference. Node selector, we simply define node selector name is equal to something, whatever the label, not just name. That's what we did, right? So now taints and tolerations is we simply add taint rule in for the node, and the tolerations rule will be added at the pod level. So it means uh, these two are work together in order to allow your pod to be running on that node. Similarly, label and node selector both are same. Similarly here. Got it? So now let's try that. How to do it? Simple. These are very simple. First, we have to apply a taint. Where to apply the taint? On the node, obviously. First, let me get the node. Yeah, kubectl taint nodes. What is the node name? This is obviously paste it. Key and the value you have to give. Anything. Let's say just name. Sorry, test one. Just for example, I'm giving this thing, but it will be different. Obviously, correct. Key value comma. We have to give an action here. In the node selector, we just gave key value, but here we have to give an action. Sorry, name is equal to. Sorry, my bad. Name is already there. It'll override it. Let's give maybe you can give anything, not just name. I'll give like this. Does not matter what it is. But I'll give something. Key is equal to value, whatever it is. All we have to do is use this thing. That's it. So now I'm applying a taint, and I told okay, key value I gave, and I'm telling again something called an action. What should happen? There are two actions. One is no schedule. Schedule, sorry. No schedule means if we deploy a pod without this label, obviously don't schedule it. That's what. Another thing is no execute. So this will do is if there are pods are running already in this node, correct? There are already pods running. Now we are applying the label after creating a pods. The existing pods also will be gone. They'll be evicted. So they'll be removed from here because the condition is not matching. Selected. So one is no schedule means for newly whatever the pods we are creating, if the taints are not matching, it won't schedule obviously. No execute means the even this will apply for no execute apply for existing pods also, where if the taints are not matching, it will be evicted from the node. It's like removing from the node. Is it clear? It's let's try it. No worries. Let's keep it no schedule. Yes, it tainted. How do you know whether taint is applied or not? kubectl describe node slash. You remember we tried it. We did this tainting at the starting of the class Kubernetes class. But that's okay. Let's see. Where is the taints? These are our own taint. We just did it right. And now when we deploy a pod, we have to use this thing in order to run this. Sorry, in order to run pods in this node. So now taint is applied. Now how to use it? In our pod, sorry, in our pod container spec, we have to use the tolerations. How to use the toleration? Simply just go here after the spec. The tolerations. What is the key? I believe disk type. Correct? That's what we gave. And operator. Operator means is equal to or not is equal to like that. So here is equal to. Equal. We can keep not equal also. Anything is fine. So first let's try this. Then I'll tell you. Don't worry. Now what is the value? SSD I believe is correct. And effect. No schedule. Sorry. Correct. This is what we gave, right? The taint command. If the disk type is equal to SSD and no effect is no schedule, then the pod will run in this node, whatever the node we have tainted. So now taints we gave to the node and the tolerations we are giving to the pod. I mean, obviously for the pod. So the taint and toleration should be matched in order to deploy your pod in the specific node. Same way as NodeSelector, but that's a pretty easy way. It is little, it's also easy way, but little different approach. That's it. Let's apply kubectl apply -f deploy. It's created. kubectl get po-n test. I guess it's running. Correct. So the taints and tolerations matched. It's running. Now let's change it. That's what we want to test, right? SSD 1. So now what happens? The tolerations what we gave in the pod, I mean the manifest file, is not matching with the taint to the node. So obviously it won't deploy. Let's try it. Let's see. Apply, yes. Created, get pods. See, they're pending because the taints and tolerations are not matching. Describe the pod, obviously. Paste it. If onion test, see, untolerated trained disk type SSD. One node has insufficient. That's what the taints and tolerations are not matching. Obviously, it won't work. So what you want to do? You have to make it correct. Simple. This is one thing. So hope it's clear and how to apply the taints and tolerations. Is it clear?
Yes,
So you're saying
the
something?
key value pair, yeah, the key value pair which we gave, right? Disk type
This
SSD.
this is what we gave,
This
right?
is something, yeah, this is something for communication between like taints and tolerations.
It's not a communication thing exactly. There's nothing to communicate. It just validates. It validates your labels. Based on that, it will create your pods. It's not a
Okay,
communication. It doesn't. There is nothing to communicate. Just validating.
okay. Then I can give any key value,
Anything I
right?
told you, right? Anything you can give, but don't give spaces and all those things. But generally, you can give anything.
Okay,
Now let's look at operator. You can use here not equal. Now what's happening here? Condition is same. If the uh, taints disk key is not equal to SSD, then no schedule. So let's try this. What happens? So we can change the operators here. Equal to not equal. Obviously, only two are there. So is equal to not is equal to. Let's see. Did I deleted it earlier? Let's try kubectl apply. Sorry, exist. There is no not equal. It's my bad. Exist. So there is no not equal. You can remove it. Equal or exist. Let's try this. See, now there is value must be empty when operator is exist. So what's happening here is with equal, it's expecting a key and a value. But with exist, let's try simply, just remove this. I'll show you. Configure. Get pods. Let's see. They're running. It's not, the value is not required. You know why? With this one, equal, it's expecting a key and value should be matched. But with exist, it's just expecting the key should be exist in the variable. That's it. It does not care about the value because we're just giving exist. If the key, whatever the disk type we gave, if the key exists as a part of labels in the node, allow it. So that's the difference. If you give equal, obviously you have to use the value also mandatorily. That's all. So no issue. Obviously it will be running. So is it clear? Taints and tolerations. Taints will be applied on the node, whatever, no matter what it is. Of course, obviously some meaningful taints, not really some random things. And tolerations has to be matched with the taints in order to work. That's how taints and tolerations will work. Pretty much same thing, right? The way, the only change I see is the way we implement these things. That's the only change. I see that one. Do you see any other change apart from this? I believe nothing. Is it clear? I mean, NodeSelector and taints and tolerations.
yes.
You got it? Sorry. So now let's go to another one similar to this. This is called affinities. Affinity is also similar. I mean, I know similar, just like NodeSelector like these, but more complex. more complex, rules that we define. So affinities, same thing. We have something called node affinity. So node affinity, we define, some labels again, and based on the label, it will be decided whether it's deployed or not, obviously. So how and how we define that? That's the only difference. So there are sorry, first, yeah, let's try the affinity. So we have something called let me write it here first. Affinity, we have three things: required during scheduling, ignore during execution. This kind of rules. This is one rule, sorry. Let me copy. Required during scheduling, ignore during execution is one thing. Preferred. Yeah, yeah, preferred during scheduling, ignore during execution. And required during scheduling, required during execution. Sorry. There are like these three conditions, where we can able to use in the affinities. So how do we use affinities is we same thing in the container spot spec. Sorry, we define affinity and we define the node affinity and we define the this whatever the label we have decided. So these three are conditions. It means you get it by this now, like required during scheduling means and ignore during execution. What does that mean is whatever the labels, whatever the conditions we are adding in order to for the affinities, the labels will be required during scheduling. While scheduling, the labels are required. It will try to match the labels, but it will be ignored while during execution, so it won't mind them. Same way here, preferred. Same way here for required. So it's required. Required means mandatory. So ignoring during execution, it won't care much about it. Preferred also similar. Preferred also, it's good to have that. It's good to have. Even not there also, it'll deploy it. Got it? Let's try this. How this will work. Vi deploy, remove these tolerations, we don't need it. And obviously, of course, remove the taint also. We apply a taint, right? But we have to remove that. Otherwise, this taint will block us. Untainted, see? Just same command I used, taint nodes command only, but hyphen I used. Hyphen means minus here, sorry. So the taint is removed. Let's say you applied a taint and you are not using the tolerations, it will block. Hey, you had a taint, you have to use the toleration to allow it. Then only it will work. That's all. Same thing. Now go here, spec. Is this correct? Affinity, node affinity. What are these three conditions we have? Required during scheduling, ignored during execution. The taints, whatever we are applying now, so affinities, it will accept these conditions. Hopefully, I'm right. The spelling, yeah, it should be correct. Paste it. Same thing. Yes. Enter nodes, node selected terms. Is it capital? Yeah. And of course, yeah, there is something called match expressions. So you have to define whatever the key and value that you have defined. What is the key? Disk type, obviously. Operator. So in here, in affinities, operator will be in not in like this. So, sorry, capital I. Sorry, my bad. Mm, and value, I'll use this. You can use multiple values like this, something. So it will try to match all these values, any of these. I mean, since we have only one value, so one is fine. So now what happens? This affinity, node affinity, will try to look for this label. If it is matching, and it will try to deploy because required during scheduling. While scheduling means while I mean deploying the pod, these these are mandatory. These operating operators, sorry, matching expressions, whatever we give, they are mandatory. But while executing it, let's ignore it. Let's write the wrong one. Let's see first. They are not matching, right? Let's see. kubectl apply -f deploy. It's throwing an error. Unknown field, obviously. I gave something wrong. REQUYRED. Is it correct? During.
Bro, ignore spelling wrong.
Yeah, exactly. Sorry. Ignore, exactly. Thank you. Ignore during execution of field. Is it correct now? Still wrong. Invalid value, blah, 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 something. No. REQUYRED, ignored, ED. Sorry. Not ignored, ignored. D. Save it. It's created. My bad. Sorry. kubectl get pod icon n running versus test. They are pending because the labels are not matching. Correct. That's error, right? Because we gave the wrong label purposefully. Where is it? Let's remove it. Save it. Apply. It will come. kubectl. Sorry. Let's try this. Still not. Describe it. Wait. Did we have? Sorry. Wait. Wrong. My bad. See, we gave this label, right? But no node does not have the same label because the label is not matching. The disk type, whatever SSD we gave, that's for tainting. We gave for taint, but we removed the taint, right? Taint won't work for affinities. So kubectl label nodes. We have to label the node. What is the node? Obviously, I have to apply a node. kubectl get nodes. Is there any label here? See, called disk type SSD? No, right? Then how it will work? I used the wrong label, which does not exist. I just gave the label only name. Let's give the label. kubectl label node. What is the node? This one. Paste disk type SSD. Labeled. Label is ready somewhere. It will be. Yes. See. Now let's get the pods. Are they running? See. It's just same as NodeSelector. Same thing. But the way we represent that is different. And that's the only difference. Got it? Now let's delete it again. kubectl delete -f. So this is called node affinity. We'll try one more thing. Don't worry. These three are there, right? This one and this, they are mandatory, of course, because now we need mandatory. Preferred, I told you what I told you. Preferred. It's okay if it is not there. Also, you can deploy it. So even if labels are not exist, it's okay. You can deploy it. Let's try. Preferred spelling. Yeah, I hope it's correct. I'll simply change this. Prefer during execution, but ignore during, sorry, prefer during scheduling, but ignore during execution. Now this will change a little. So now we'll be adding the weight. Sorry, at one preference. Because we are using preference one, you can remove this node selector terms. Match expressions also not required. Running all should be fine. Let's try. Obviously, first we'll try to apply it. It's created. Of course, it will be running. All good. Now let's delete again. Try, SSD1. Sorry. Apply. Created. Get pod. Still they're running because it's not minding the value. The key exists, right? The key disk type exists. That's fine. Let's try again by changing the key and the value. Both will give wrong. Let's see. Maybe disk, blah blah blah, something, whatever. Let's created obviously. Still running. See, it does not matter. Even if it does not exist, of course there won't be much use for this, but obviously you can use this also. So I told you, right, a few differences here. This almost similar. This is little different, preferred, good to have. So that's why we call it soft affinity, and these are hard affinity. So what happens here is hard affinity means it should match the label. Hard affinity, that's what happened, right? You've seen it. Pod affinity means, sorry, soft affinity means it's okay if you don't have also. Of course, we don't use much, but yeah, this is what happens. Is it clear? Is it clear?
Yes.
In affinities, this is affinities about the node level, right? I mean, we have apply the labels. Based on the labels we define the node affinities. There is something called pod affinity. What is this pod affinity? What does it mean is their pod affinity depends on another pod. Let's say you want to run a pod and you want to run the pod if another pod is running in that machine. Let's say I want to run pod B, and I want to run this pod B only if pod A is running in that node. If pod A is not running in that node, I don't want to run it. So like that. So it will make sure the pods are running in, try to run in that node where other specified pods are also running. Got it? So let's say, as an example, pod 1 is already running in one node, let's say test node. I'm trying to deploy pod 2 and uh, I'm adding a condition that if pod 2, sorry, pod 1 is running in that node, then only run this uh, pod also in that node. If pod 1 is not running, don't run in that node. So it depends on another pod. We are creating the dependency on another pod because my requirement is I want them to be running in the same node. Why? Of course, you may ask why it is required. It's required, when you want to, let's say front end and back end is there for your application. So you want to run them in the same node for performance issues. So that's why I want to run the same thing. For the time, we'll be using these kind of things. Correct? So this is called pod affinity. Same, we'll be using the same thing. These conditions required during scheduling, I mean, ignore during execution. Same thing we'll be using. Let's try. Deploy, obviously. So instead of node affinity, what we write? Pod affinity here. So that's it. And same thing, required, sorry, required we want now, not preferred. We want required. So required weight you can remove. Sorry. Required label selector. Now, if you remember earlier, node selector we were using, right? In order to identify the nodes, because that's what the labels were are there. Now we are using a pod affinity. So pod also have labels, right? Obviously, where is the label? If you see here, the labels exist. The labels see the labels exist. Now, what we are creating pod affinity depends on another pod we are creating like that. So you have to use the pod labels. Now my requirement is label selector, obviously match expressions, correct? Key I have to change. What is the label? Maybe app, something app in HTTPD. That's it. Now what's happening is like if uh, the pod called the pod named, I mean whatever the label pod has, like app is equal to HTTPD running in that node, in whatever the node. So run this whatever the test pod also in the same node. So we will be adding one more key called topology. Topology key. So what we do here is like we'll be defining Kubernetes.io/host name. It is just to filter out the node where the HTTP is running. So now what happens when we try to deploy this test deploy, whatever the pod, it will check for this app is equal to HTTPD label pod. I mean the pod which has this label. So if the pod exists, I mean if the pod exists in one particular node, this pod also will try to deploy in that node. Let's see. kubectl apply hyphen sorry deploy created kubectl get po, obviously in the pending state. Let's describe, because the pod definitive we gave, oh wait sorry, is not matching. See, how do I know it's not matching? Of course this is the error, did not match the pod affinity rule. One more thing is there is no other pod running here. If you see, this is the pod which has the label app test. See, this is not running. Let's see. Let's apply kubectl apply hyphen app httpd. It's running. kubectl get, sorry, it's still run. Wait, it's still 0 by 0. Let's patience. 1 by 1 running. Wait, cool. It has sidecar container, I guess. It will take some time. Yeah, it's running now. It will also come. App is equal to httpd. That's what we give. Now let's verify app in httpd. If this is matching, it will be deployed. Now it will be in a pending state. Why it will, in pending state? The label is there, right? Why still it should be running? Why? because the condition see required during scheduling. It means while deploying itself, the label should exist. The pod label should exist. After scheduling, we cannot do anything. We are ignoring it. So while deploying itself, this should exist. Let's delete it and recreate it. Get pod, it will come. Let's describe. Yes. Sorry. I'm forgetting this namespace. Oh, did I still have the taint? I think I should remove it. That's okay. Let's see. kubectl get nodes. Still, it is not on. It should work. Let me try. Obviously, it's still pending. Sorry. Prod. They're running. Cubes. Let's open the file. VASTTPD. Blah blah blah. All fine. Template app is equal to HTTPD. Okay. This is the one. That's obviously correct. Now deploy. And this also should be correct. For affinity label selector, match expressions, obviously correct. Key, app, okay, app is correct. Operator in, correct values. Topology key, is it correct? Yeah, it should be correct. Alright, it will fail. All good. Still not working. Where? Where we missed. Still pending. Somewhere we missed it. Let's remove this also. Let's remove all this. Okay, that's okay. Even though it's there, no issues. kubectl apply -f httpd deploy. It should be fine. Required during downtime. Sorry, during scheduling. Blah blah blah. These are all fine. kubectl get pod. They're running now. kubectl apply -f deploy created. Let's wait for a few minutes. Not few seconds. I mean. Let's see if it is still not running. We have to. There is something wrong. Still same. Let's see. Let's figure it out. Nope. Still not working. Where I missed. All good. All good. Yes. And why the hell it is not working? Same thing. Let's describe it. Scriptural describe deploy slash httpd. Label C app is equal to httpd. Correct? All good. Now let's open our thing. Yes. Oh, same thing. Affinity. Yes. Pod affinity obviously required during this is fine. Label selector. Match expressions. Key all correct. Not sure what's happening. But let's see. Let's remove this topology key. Let's try now. It is required. Wait, let me add the topology key. Okay, this is correct. Created Gitpo. Nope, something is wrong. I mean, configuration is correct, but still, it is wrong. Yeah, that's okay. Meanwhile, I'll check it. What's the issue? Then we'll see. I'll let you know. Okay. But the working, how it works, the pod affinity, how to define it. Is it clear? Any doubts? Is it clear? I mean, so far, can you hear me?
Yes, bro.
Yeah. Not only this, there is one more thing. Of course, these two are fine. Affinities, we have seen node affinity and pod affinity. There is something called anti-affinity, which is reverse to this. So now you just seen pod affinity, right? So if the pod is running in that node with this some label, this pod also will run. I mean, depends on the label. That is pod affinity. What does it mean, pod anti-affinity? It will do the reverse. When you want to deploy our application, let's say pod B, if only if the pod A does not exist in the node. Pod affinity is it should exist. Then only pod B will run, correct? Anti-affinity is pod A should not exist. So like that. How to use it? Same thing, except instead of pod affinity, you'll define anti-affinity. Where is it? Yeah. Instead of pod affinity, define anti-affinity. Now what happens? It will try to look for it. If this key app is equal to httpd, this label a pod exists in that node, then this pod won't deploy in that node. It will run in different node. So like that. So like that how it will be. Anti-affinity. Similarly for node affinity also there. So node affinity, what we did generally, we define some node selector labels. If they are matching only, deploy it, correct? That's what we did, right? But in the node anti-affinity, so what happens is, if the label is not matching, then only deploy it. If the label is matching, don't deploy it. How do you define not in here? Not in. That's the only difference. Here, affinity will be there. Sorry, node affinity only, not anti-affinity. Like this only. Everything is same for node affinity except only the operator will change. Node affinity is if the operator and the key and value are matching, it will deploy in that node. Anti-affinity means if the key and label are matching, don't deploy in that node. The reverse. Same with pod affinity. Pod affinity is like if the another pod is running in this node, then this pod also should run in the same node. Anti-pod affinity means the pod should not be deployed if the other pod is running in the same node, like that. So affinity or no anti-affinity. So you do practice it. I'm not showing you here. So try to practice it. So is it clear? That's all about today's class. It's all about scheduling the pods today. Where we schedule, how we schedule. That's it. I mean, of course, where and how it. So let's a bit more conditions we're adding. So node selector based on the labels, we define label for the node, any label, and we use that label to deploy a pod in a specific node. Taints and tolerations is also similar. So we apply a taint to a node and we define the tolerations in the pod. If that both are matching, then try to run it in that node. If they are unmatching, it will be in a pending state. Same thing with affinity. Node affinity, first thing is like based on the labels, it will deploy in that it will deploy the pod in that node. If it is anti node affinity, it won't deploy in that node if the label is matching. Next thing is pod affinity. Pod affinity, if the one another pod is running in the same node, this pod also will run in the same node. Anti pod affinity means if another pod is running in the same node, this pod won't run in that node, like that. All are similar if you observe, all are same. The way we represent, the way we define, they are different. The meaning all are same. So is it clear?
Can be declare both node affinity and pod affinity in the
Try
same
it.
manifest file.
Try. There is nothing wrong.
Okay.
Try it. Find out.
Mhm.
I never used it, but try it and find out. Let me know if it is working or not.
Sure.
Got it? So far any doubts? So no doubts, then we can close it. And of course, sorry for 2 days. I had a meeting, so I had to jump in that so that we couldn't have class. Tomorrow, same time, 7 a.m. Sorry, not same time, 7 a.m. Tuesday, right? Sorry, yeah, Tuesday, 7 a.m. Our regular timings. So we'll have class, okay? I don't have anything, so we'll do it. We still have 4 more topics to discuss. By Friday, we'll close it. Small topics, but it's fine. No need to rush it. So is it clear?
Yes.
So yeah, that's it for today. Let's meet tomorrow 7 a.m. Then do remember 7 a.m. or p.m. If it is, I'll let you know if timings change. But 7 a.m. is fixed for tomorrow. Okay. All
Okay.
right then. Have a good night. Bye. Bye all.